Well, welcome back. We're going to start our section on medians and altitudes today. So we're going to start right off the bat with defining what a median is. And a median is a segment where the endpoints are on the vertex of a triangle and the other end connects to the opposite side and it bisects the opposite side. When we have all three medians in a triangle, they are concurrent, so they will all meet at a single point, and that point is called the centroid of the triangle, and sometimes we also call that in science the center of gravity, and it's always on the inside of the triangle. I know some of these specific points could be either on the triangle or in the triangle or outside of the triangle, but in this case the centroid is always inside the triangle. So our first theorem that we're going to talk about will allow us to solve some problems because of the relationship of the different segments of the median. And the medians are concurrent at that centroid point, and that centroid is 2/3 of the way from the vertex of the angle in the triangle to the opposite side. So the centroid is located 2/3 of the distance away from the vertex to the midpoint of the opposite side, which also means that the centroid is 1/3 of the distance away from the opposite side. So we're going to be using that theorem right there called the concurrency of medians theorem to go ahead and solve problems with our triangles. So here's an example. It says in the diagram at the right, we know that the distance from X to A, so from the vertex of the triangle to the centroid, is 8 units, and they want us to find the total length of that median right there from X to B. So A is the centroid because it's the point of concurrency of all three of these medians. So we're going to go ahead and set up an equation where XA is equal to 2/3 of the distance of XB. And so that's what I want you to get into the habit of doing, is writing an equation for that. And it's always the distance from the vertex to the centroid is equal to 2/3 of the whole thing. Okay, so then we can substitute in what we know. It says XA is equal to 8 up here. So instead of XA, we're going to write 8 is equal to 2/3 XB. Our goal is to solve for XB, so we need to get rid of that 2/3, and we do that by multiplying by the reciprocal, which is 3/2. And whatever we do on that one side, we have to do on the other. So when we multiply these two together, 3/2 times 8, we multiply 8/1, and we get 24/2, which is the same as 12. So here's one for you to try. Go ahead and pause the video. You're using the same diagram, and they're going to tell you the distance from Z to A is 9. Find the length of Z to C, and then find the ratio. Once you get that answer, we already know ZA is 9. If you take ZA, that 9, and divide it by what you get for AC, what is that relationship? So go ahead and pause the video, and we'll talk about that when you get back. All right, I hope you had a chance to take a look at that. Let's take a look at what we need to do here to find out what the length of ZC is. I went ahead and had this written up ahead of time, so hopefully you can follow through with or understand what's going on here. So ZA right here is equal to 2/3 of ZC. That's our first equation you need to set up. Substitute 9 for ZA, multiply by the reciprocal to get ZC by itself, and we end up with the total segment, or the total median, being 13.5 units long. So in order to find the ratio of ZA to AC, ZA we already know is 9, and we know ZC is 13.5, so that leaves a distance of 4.5 for A to C. So the ratio of ZA to AC is 9 to 4.5, which is a ratio of 2 to 1. So this distance to the centroid is twice as long as the other distance. All right, in this triangle, we are looking at the altitude of the triangle, and the altitude is a perpendicular segment, and it goes from the vertex to the opposite side, and this altitude could be inside the triangle, it could be on the triangle, or it could actually be outside of the triangle. And every time we have an obtuse triangle, that altitude will occur outside of the triangle. When we have an acute triangle, it will occur inside the triangle, and for a right triangle, it will be on the triangle. So you could have any of those three scenarios. So here's another problem for us to work out. For this triangle that we have, PQS, they're asking us, is PR, the distance from P to R, is that segment right there, is that a median, or is it an altitude, or is it neither? Well, a median goes from the vertex of the triangle to the opposite side, but it bisects the opposite side, and that is not the case for this one. However, this one is perpendicular to the opposite side, so this one is definitely an altitude. So I'll go ahead and write that one in here for you. That one is an altitude. Actually, I'll just circle that. It'll take less time. The second one says, for triangle PQS is QT. Now we're looking at the segment from Q to T. Is that a median, altitude, or neither? Well, it's not an altitude because it's not perpendicular. However, it is bisecting the segment, and it is going from the vertex of the triangle to the opposite side. So in this case, this one is definitely a median. All right, here's a couple for you to try. Pause the video, see if you can come up with the answers to these, and we'll go through them when you get back. All right, the first one is segment AD, from A to D. If you look at that segment in the triangle, D is definitely the midpoint of CB, so this is bisecting the side, and it's going from the opposite vertex, so AD is definitely a median. Segment EG, well, it doesn't go from a vertex of the triangle, okay? So it does bisect the side AC, but point G is not at the vertex of the triangle, so that one's a neither, okay? And then lastly, segment CF. CF goes from the vertex of the triangle to an opposite side, and it's perpendicular, so we call that an altitude. Here is your lesson check. Go ahead and work on these 4 problems and bring your answers to class tomorrow. See you next time.